Hello, everyone. What's up? Can you hear me, Matt?
Yes.
Okay, I will try and talk into it. Welcome, everyone, to the late night show. I'm glad we at least have a few people. I was worried it'd only be the three hecklers that are drunk up here, but yeah. Anyways, welcome. I am Joe. So a couple things before I get started here. One on the name of my talk. So a handful of years ago, some of my coworkers went to this security conference in Madison, Wisconsin, and they were watching this presentation, and the guy was talking about using tools of yesteryear, and he referred to them as boomer tools. And my coworkers, being the jerks that they are, came back to me and tried to mock me. It's like, Joe, this guy was talking about things that you had a hand in. He called them boomer things. And it's like, I thought about it, it's like, should I be upset? Nah, because somebody's actually using something that I was a part of, so this is really cool. I'm gonna latch onto that. I myself, believe it or not, am not a boomer, but the era of security that I worked in for pen testing, I would say is boomer-esque, right? So my talks on these things, on these boomer tools, will forever be boomer security, BoomerSec. Second point before I really get started here, right? So I've sprinkled in a number of pictures over the years of our old team throughout my slides, doing our work back in the day. This picture here was us doing a wireless assessment for a large Milwaukee-based firm. Doing a wireless assessment, we're not what you would call stealthy or covert, right? That's me in the car, that's Matt's FenFen's vehicle, the Lexus mobile hacking unit. We sat in this parking lot probably for the better part of a day. No one said anything to us, right? And I think we got domain admin. And at least 20 years ago, if you just went in on being a geek, people didn't want to talk to you and they just let you be. So it was wonderful. Okay, so a bit about what I plan to discuss. The first half of my career, it was focused on Windows passwords and how to really abuse them. And this talk, it's going to be mostly a history lesson, and there might not be a whole lot new if you're a seasoned pen tester who's doing current work. But hopefully you found some good beverages and it's going to get you through the next hour. And I'm going to talk really about Foofus.net, the team that I worked for, and how we contributed to the industry during that time. And then I'm going to wrap up with some current stuff that I've been playing with, which may or may not turn out to be useful to a few folks here. And I should really note that I'm talking about legacy Windows passwords and that sort of thing, not passwordless authentication, not zero trust or whatever buzzword of the day others are talking about. So first off, who am I? As I said, I'm Joe, Jomokan, JMK. That was me a long time ago, and if you know your memes of the early 2000s, that's where my hacker handle Jomokan came from. And I spent the first 15 years of my career working as a pen tester, security consultant, right? And I was very fortunate to be part of this amazing team based in Madison, kind of in the early days of the whole pen testing industry. And during that time, we contributed tools, content, and other things to the community under this name, Foofus, some of which I'll cover here tonight. About 10 years ago then, I left pen testing and I joined an internal IT team with the goal of using my offensive experience to apply to their defensive controls. So the start of my kind of security journey in many ways was actually this post to the NT Bug Track mailing list back in 1997. In it, a security researcher posted a very simple patch to the Samba source code. Now, Samba, of course, is this open source tool, right? It was released in the early 90s as a way of talking to Windows machines from non-Windows machines. And the patch, it modified the Samba client to use a hash of the person's password in lieu of their actual password. And when this was first shared back in '97, I was a college freshman, and hacking wasn't really my thing yet. But I came across it a few years later, and it became the foundation for all of my eventual research and development. So let's take a minute or two and kind of dive into what that post is telling us and why it matters. So Microsoft Windows, it stores passwords for local accounts using LM and NTLM hashing algorithms. These are values that are stored in the SAM registry hive for local accounts on workstations, domain member servers. They're stored in the ntds.dit file for domain accounts on domain controllers. And LM, NTLM, they're one-way hashes, right? You can't simply decode that value to get the password back. LM is the older of the two. Came out of the 80s, OS2, right? And it's now been disabled for many years by default. And it's an interesting algorithm in the way that it works. So say you have a password of cricket8. The first thing it does is it uppercases that password. It then splits it into two 7-character chunks. Everything beyond 14 is just dropped. And those chunks are used as a key to des hash this magic string that starts with KGS. And the resultant value coming from it, they're concatenated back together to become the LM hash for that password. Yep, there we go. NTLM is the newer of the pair, and it was released in the 90s, right, with NT, and it does away with some of the shortcomings of LM, and it's a much simpler kind of algorithm, right? Take the password, MD4 it, you have a hash. And you no longer have this case problem where it uppercases it, right, and you can have much longer passwords than 14 characters. But both of these algorithms, they have a couple kind of key vulnerabilities that I'm going to focus on. Now, again, the hashes, they can't simply be decoded, but they are susceptible to things like offline brute force cracking. LMs obviously are very easily broken, right? Because at most, we only ever need to crack a 7-character uppercase password. And they're also highly susceptible to pre-computed table attacks, referred to as rainbow tables. So these tables, they trade storage for compute. It allows you to do a lot of math once, and you can then look up a hash to get its password, essentially. Now, on the flip side, NTLM hashes, for a good password, are reasonably hard to crack. Fortunately, as a pen tester, most passwords aren't good, right? So, and then the other kind of wonderful thing about LM and NTLM is they don't use what's called a salt, and that makes this thing called passing the hash feasible. And what that means is that if you have two accounts, they can be on separate systems. If they have the same password, they're going to have the same hash. So let's assume we have this machine here, 3 local accounts. These are the hashes for it. And some bad guy gets on there, and he extracts those hashes. He then takes those hashes and he sprays them across the network, right? And he finds some other machine that has a local account with that same password hash. And it allows that attacker then to use the hash to log in remotely to that machine. Never needs to know what the real password was. So now let's backtrack and look at that original kind of exploit that we found on NT Bug Track in '97. And it's this if-else clause that is kind of the magic bit of that whole patch. So in normal execution, when somebody uses Samba and they give it a password, it ends up calling this SMB encrypt function, and it does that LM hashing thing, right? Splits it into 7-character chunks, uppercases it, gets an LM hash. But if you now, using this patch, give Samba a hash, we bypass that step, and we skip over the LM piece, and we just use the hash directly. So it's that simple tweak to the code that allows me as a user of Samba to not need to know the password, to just have that hash. Of course, back in '97, Samba didn't do all that much other than basic Windows file share, printing, and that sort of thing. And it limited the effectiveness as an attack tool. Nonetheless, it was pretty much what all of our work was based on for many, many years. So this here is my coworker, at the time, Fen, right there. So that, that era, there was a thing where lots of companies had like free soda and stuff at work to energize us, and Matt developed a bit of a drinking problem there. But, so, yes. So we're talking 2003, right? The Foofus team is about 5 years into its existence, and it's starting to kind of build this successful penetration testing practice, and we've really started to engage with the greater security community. So let's kind of set the scene a bit for the early 2000s. So back then we were dealing with Windows NT, Windows 2000. At that time you had to manually patch these things. So most people didn't.
Sucks.
Yep.
Sorry, I worked at Raytheon and I know about manual patching. But now I work for CDW, it's great.
Excellent. So yes, manual patching, and everything was internet facing, right? Because we didn't know how to use firewalls at the time. And everything ran default services. So NT4, if you remember back, if you're old enough, by default installed Microsoft IIS, the web service by default, right? And the thing ran a system. It was admin on the box. And had a bunch of vulnerabilities. And because of all of that, it made for it being the heyday of internet worms, right? We had Code Red, we had Nimda, we had Blaster. And all of these things were created in somebody's basement, and their goal was simply to spread. Unlike today, where we have ransomware, we have like truly evil actors who are set on ruining things. The attackers of 20 years ago were much nicer, just more annoying, I would say.
I don't know.
But attacking stuff then wasn't always especially hard, right? So I'm showing a URL here with these ... slashes in, right? This is a directory traversal exploit, right? You're requesting a file on the web server, and you're saying, hey, web server, just step outside of that web root and pull down this file from the operating system's directory, right? I'm grabbing here the SAM registry hive. It's that thing that contains the NTLM password hashes. And then I'm feeding it to a different tool of that era, Loftcrack, which extracts the hashes for me. And then I can use those hashes now with a Samba patch, right, to do something. And at this point, we're a few years removed from the 97 Samba patch, so on the Foofus team, we created our own, because Samba could do a lot more at this point. And we released our own version of that to the world. In our patch, it allowed you to take one of those hashes, set it as an environment variable, and then utilize any Samba client utility to do a pass the hash. And what I'm doing here is I'm connecting to a remote server, I'm executing some commands that create myself a local account on there. And this patch, it was the go-to solution actually for a lot of people for a handful of years. It also became kind of the foundation for other tools. So 2012, we had the Pass the Hash toolkit, which if you looked into it, actually had our patch as its core, which was kind of cool. And even just a few years ago, somebody sent me this photo. They were taking a SANS course, and that stupid manual referenced my patch. I mean, like, this is years removed, right? So stealing the SAM from a single machine and using it is fun, right? But the scale is kind of limited. So around this time, we saw that passwords were getting shared around a fair bit, right? Users might have accounts on multiple systems, same password. Or you might have a built-in administrator account, many hosts, same password on all of them. And we wanted some method to quickly find where a password or a password hash was in use. And we had a couple different tools available to the community from others for doing password type guessing attacks, right? The first was this SMB auditing tool. And it was incredibly quick to do SMB brooding against a single host given a word list. There was also this thing from the hacker's choice, THC, called Hydra, which was more of a general purpose password guesser, again, against a single host. So what we did was we took these two open source tools and we mashed them together. And we took the ability to do Samba, SMB brooding, we added it into Hydra. We added in passing the hash because we love to pass the hash. And then we also made it do host testing concurrently. And we fed that back into THC. They released a new version of Hydra that year with all of our updates. And we could now pass hashes around a network quite quickly. So I've been incredibly fortunate over the years to attend a variety of security conferences. This one, obviously. DEF CON is probably my favorite and what I've gone to most years for the last 2 decades. In 2004, this is our fearless leader, Foofus, and he was giving his first DEF CON presentation on our work. So in 2004, right, we're spraying passwords all around like crazy with Hydra. But this fire hose approach, it works, but it's not efficient, right? So we wanted to know where accounts existed, and then we could target them specifically. And we also wanted to know the target's lockout policy. It turns out that if you lock a lot of accounts, customers are sad, right? So we needed to know the lockout policy so that we could not make them sad, and it just allowed for a more efficient attack. So during that presentation, Foofus talked about Owner, and we released this. It's the opportunistic Windows network reporting tool. And it was an open source tool that abused the Windows native APIs to enumerate all sorts of data about Windows. And it spit the data back in comma-separated values that we could consume and base our attacks off of. If you're familiar with Bloodhound, which I assume some of you are, since it's awesome, its collection's actually done in a very similar manner using some of the same APIs. But now, you gotta think back 20 years ago, the world was slightly different, and we could actually gather all this data anonymously, right? So I'm showing here doing a net use command to a server, no username, no password. It's a null session to the machine. And it's sufficient to be able to enumerate data from it. So here I'm using owner to extract the lockout policy. Here I'm using owner to tell me all the local accounts on that machine. I can get their group membership, I can get their privileges, all of that good data. Because if we have that data, it can then inform how we do our password guessing, right? If I know that thing's a lockout policy of say 6 attempts in 30 minutes, I'm gonna do 5 attempts, I'm gonna sleep at 30-minute time and then do 5 and I'm gonna repeat indefinitely, right? And if I also have this list of users that I know are enabled, I can really focus in on them. So this led to kind of our development of what we called the shallow password guessing approach. And the basic idea was that you had a big user list, small handful of passwords, and your odds of getting something to pop were incredibly good. And around then, the world was starting to transition from just very basic passwords like password to having password policies that enforce complexity, 8-character lengths, rotate every 90 days. So what you saw was that people started making very predictable choices, right? Season-based passwords. Winter 2004 as an example. And this whole idea, it sounds like simple, obvious, right? But the concept, at least for us, was a game changer to how we approach pen testing. And at that point, most organizational compromises for us were through password guessing. I mean, we would exploit vulnerabilities kind of if needed, but finding 0 days or developing 0 days, that's kind of hard. And and the life of a 0 day, right, is often short-lived because maybe somebody will patch it. People picking stupid passwords, I mean, that carried us for decades. So, end of 2005, the Foofus team decided to kick it up a notch, right? And we released a couple of different tools, one of them being Medusa, the other being FgDump. This here is a picture of our shared office at that time. Now, I'm all for the ability to have remote work these days, right? I wish my employer actually allowed it a little bit, but different story.
Where was this office?
This is in Madison, Wisconsin, right? And for me, in my early kind of career development, being locked in a room for years with these geeks, and it was critical to my development as a pen tester, and I think our tool development overall. Just being in a room together and bouncing ideas off of.
Made you itch.
Yes. So, the first of these tools, right, Medusa. It was our replacement for THC Hydra. We wrote it from scratch in C, a modular approach using thread-based. And it handled SMB brooding, of course, because we loved SMB. And it did 2 other dozen protocols as well. And it was fast for what we wanted it to. We would do hundreds of SMB connections per second with it. And Medusa was my baby for the next decade, and it's what I spent all of my hacking time really working on. Now, for me, the downside of when I switched jobs in 2015 is that I no longer had time to devote to Medusa. However, kind of for this talk, I decided to dust off the code just a little bit, right? And I put out a new release for the first time in about a decade, right? And the key feature of it is it now finally supports SMB v2, v3 with SMB signing. So it's maybe useful by somebody again. And I also cleaned up all of the code that was a decade old related to OpenSSL, so that hopefully it can stay in Linux distros for another few years. And to be honest, I've barely touched C in a long time, so I did kind of what every other crappy, mediocre coder does these days, and I went to ChatGPT. And I didn't understand the code I wrote 10, 20 years ago, so I fed it to ChatGPT. And I was amazed that it seemed to understand it better than me, and it could explain some of it to me, which was handy. I then asked, it's like, okay, I have all these deprecated SSL calls. Can you replace them? And it was amazingly confident. It's like, yes, Joe, I can replace these with current OpenSSL calls. And it spit stuff back that looked reasonable. It was all wrong. And I told it it was wrong, and it's like, oh yeah, you're right, it's wrong. Here's some other stuff. That was wrong too. Eventually, we got to something that worked. But where ChatGPT did come in handy is that I said, okay, I have this tool called Medusa. I probably should get a new logo. I don't know who created this one, but it's been out on the internet. So it generated this. This is current Medusa. Isn't she beautiful? So here's a quick image of me testing my new Medusa code, right? And I'm hitting a Windows 2019 server, and I'm feeding it a user list of 1,000 different accounts with a single password. And what it's going to do is it's going to check all of them in 2 seconds, and we find that this doofus Jomokin has a password of, what, winter 2024. So, yay, it works again. Okay, so late 90s, early 2000s, there were a handful of these PwDump kind of utilities that people were using to extract hashes from boxes. The original PwDump 1 was released in 97, great year, created by Jeremy Allison, who also created Samba. And the purpose of the tool was to allow people to extract hashes from Windows to transition over to Linux, yeah. PwDump 2, released in 2000, and it introduced this technique of injecting itself into the LSAS process, the thing that handles Windows authentication. PwDump 3 followed that, and it allowed you to do it remotely. And at that time, we were huge fans on our team of this thing called PwDump 3E. But around then also, Windows started to introduce DEP. This is the Data Execution Protection functionality. And when you start messing around in LSAS memory, as PwDump 3E did, and DEP is enforced, you tend to crash LSAS. And this is what popped up, at least at that time, when you took LSAS down, that it's gone, you have a minute or two, and the system's going down. And there's nothing you can do at that point. And if you do this on a customer site and you do it at scale, they get sad again. And also around this time, people started to deploy AV to workstations, to servers, more consistently. And AV, early 2000s, right, it's not good, it's not useful. It was necessary, maybe, I don't know. But, and the way it tended to work is that you would extract hashes from a machine. A few minutes later, McAfee or Symantec would pop up a message saying, hey, I found a bad thing, I stopped it. It didn't. Then it would blue screen the box. Again, customers sad. So because of these things, we created this tool called FgDump to solve the depth problem, the AV problem, and also to scale our challenge of extracting hashes across many, many hosts. And our buddy and coworker, FizGig, was the kind of key architect behind FgDump. And him and I was there when he was building it in a bar outside of Gary, Indiana, of all places. My job was to feed him beer, he coded, great things happened. And he wrote PwDump 6, which disabled DEP, so we could do the extraction without DOSing LSAS. And he wrapped it in FgDump, which would remotely log into the box, pause AV, so we could do our things, and then resume AV. Because back at this time, if you had a command prompt on a box, you could type net stop McAfee. You're good to go. Symantec, on the other hand, had like a registry key that said turn security off or something, and you'd put a 1 in there, and then you're good to go, and then you'd flip it back. It was wonderful times. So we released this thing called FgDump to the world at that time, and it was by far, at that time, Foofus.net's biggest hit. At our peak, we were getting something like 10,000 downloads of it per month. And if you saw on the previous FizGig's Funhouse website, we'd placed Google Bucks ads on there. We were making literally like dozens of dollars per month off of this thing. It was amazing. It bought us at least a few beers at DEF CON. So great. But even cooler than that, our tools, FgDump, Medusa and stuff, they started getting picked up by various websites would talk about them. They were put into some of the hacker books of that era. I was reading Mitnick's Ghost in the Wires, which I really enjoyed, and especially because at the start of it, it talks about him breaking into some office and running this tool called FgDump on the person's workstation. I'm like, dude, I was there. I had a hand in that. It's awesome. So we were riding high, right? And we're like, we released these things, all good. And then Matt came along and actually topped our releases by posting this stupid video of him shooting a rock and that rock exploding. And it became like a meme of that day, and it was linked to from all these blogs, and it was by far the biggest hit of our team. So if anything is remembered of the Foofus era, it is the exploding rock. It funded DEF CON beer, yes. So, okay, now we're at 2006, and we're highly efficient at compromising Windows domains, right? Generally, this involves you pop some workstation, you steal the local admin password, you hop across boxes, you steal some more accounts, you get domain admin, you win. And we document this process for customers in our reports. And, well, words, they tell a story. Well, we wanted some way that the customers could visualize what we're describing. And it led to Foofus's work on applying graph theory to implied trust relationships from shared credentials. So at DEF CON 14, he shared some of our work, and he asked the community at that time whether using graph theory for security was awesome, as we believed, or simply bullshit. The response, amazingly, was that nobody seemed to care. They kind of shrugged and they thought it was bullshit. But our basic premise of the argument was that organizations were viewing their environment just as these sets of lists, but as an attacker, the assets, they're not on lists, they're really connected through these relationships that can only be best described by a graph. So this picture here is an image I made probably 20 years ago. In it, each blue dot is a system at the target network. Each red box is a unique local account credential, the NTLM hash. The Pac-Man that we got going there, that's because there's 1,000 systems at this environment that had the same local administrator account password hash. And the thing we were trying to convey to the customer is that a compromise of any single one of those 1,000 is essentially a compromise of them all. The picture here is of more modern, free and open source Bloodhound, right? And it's in some ways prettier than our original one, and it certainly covers more than local accounts. It has domain logons, and it's dynamic. You can search it. It's a cool tool. But the basic idea is the same. It shows how accounts and systems are connected in ways that one can abuse them. And I assume that many of us have now also seen this quote from 2015 about how attackers are thinking in graphs, right? And I would argue then at this point, Foofus's original kind of DEF CON question was now thoroughly answered, right? And that the world had come around to seeing that graph theory on security problems is indeed awesome, not bullshit. It just took everyone a decade or so to really take it to the next level with Bloodhound and stuff. And I'm very fortunate to where I work. We have Bloodhound Enterprise, and we're a customer of it. And we're also on their advisory board. So a few weeks back, I was at a CAB meeting there, and I shared that Pac-Man picture and some of Foofus's original work with Rohan and some of the main developers of Bloodhound. And Rohan, I asked him, it's like, well, haven't you seen some of Foofus's stuff? And he's like, no. And then he's a jerk. He's like, I was in elementary school then. And reminded me, it's like, we're old, but. Okay, so now here's a picture of us post-Hacker Jeopardy at DEF CON. If you're ever to DEF CON, I highly recommend checking out Hacker Jeopardy. It's amazingly stupid. It is so awesome. I love it, right? And this is a number of my old gang. We have Foofus and his outfit on the way left, Fen there and stuff. Dan Kaminsky in the orange was not part of our team, but truly one of the great security minds of our era and one of the just great educators to have ever kind of given us stuff. Okay, so when we talk about NTLM, we're typically referring to one of two things, right? The first are these NTLM hashes that I discussed earlier, right, to store credentials on a server. The second is the network authentication protocol used to authenticate a client to the server. And this protocol, it doesn't directly send the NTLM hash to the server. It instead uses a challenge response handshake to prove knowledge of that value. And the NTLM hash, it works basically like this. The client sends a request to the server. The server then generates a random challenge that it gives back to the client. And now the client needs to formulate some sort of response. And being in typical Windows fashion, it takes the person's password, generates NTLM hash, and then splits it into chunks again, right? And each chunk is used to des hash the challenge. Those values are concatenated back together. That is your NTLM v1 response. The server more or less does the same thing on its side and compares the two, making a determination of whether you are authenticated or not. So in this conversation, up until now, we've been focused on the attacker being the client in this authentication process, right? But there's value in the reverse scenario where the attacker is actually the server. Because if we can capture these responses, we can do things with them. We can maybe try and crack them, right? And in NTLM v1, the only kind of random bit of data here is that challenge coming from the server. We control that, so we can fix that value. In addition, that whole splitting of the hash in order to come up with the response, that makes cracking that response exponentially easier. The difficulty, though, in abusing this is how do we capture the NTLM responses? And we do that by coercing a client into connecting to some rogue server we own. And we solved this in a couple of different ways that really worked equally well for us for many, many years. And the first abused how a Windows client machine finds a server it wants to talk to. So in most cases, right, your client is going to ask the DNS server, where's my server? DNS responds back with an IP, the client talks to that machine. Well, what happens if the client asks the DNS server something it doesn't know? Well, in Windows, it generally sends out a broadcast request saying, hey, who out there is the machine that I want? And if you are a rogue machine in its broadcast domain, you can listen for these messages and you can respond to them. And if you are the first response to get back to that client, it connects to you. So my example here shows WPAD, which was the host name that Internet Explorer used to discover the proxy to send stuff out, right? Most organizations never had a DNS entry for WPAD. So if you're doing a pen test, you would just see all sorts of requests for WPAD out there, and you could easily respond to them. Now, that broadcast-based approach, it worked really well for internal kind of populated networks. There were times, however, though, when we wanted to be more targeted with our coercion efforts. So this kind of seemingly innocent email, it actually allowed us to compromise a seriously large number of accounts, including domain admins. The magic bit in it is this image source link down there that's highlighted. Points to a 1x1 white pixel. That's immaterial. The key part of it is that rather than pointing to an HTTP web URL, right, we've replaced that with // or you could put file : what that does is it tells the client, your email client, to use the SMB protocol to retrieve it rather than HTTP, a web request, right? So that client would reach out to, of course, a Samba server that we'd modified and hosted on the internet. And we'd tell it, okay, you can have this image, but you need to authenticate. It would do a challenge response. We'd log that, right? And at that time, most organizations didn't do any sort of egress filtering. So this traffic was allowed out. In addition, most people didn't have split accounts. So your IT staff was logging in as domain admin on their workstation and checking email. So for us, we could quickly identify IT staff at an organization. I could send this email, and within seconds, because it only had to show up in their preview pane, we'd have the challenge response back, we could crack it, and we'd be domain admin. Wonderful times. I've recently heard that these sorts of coercion attacks are being called bring your own victim, BYOV. It works for me. So 2007, we released an updated patch for Samba to perform the fixed challenge response capture. And it also added in this broadcast capabilities. It was about 5 years after that patch then that Responder was released. And that's kind of the go-to tool these days for it. And it does basically the same thing, plus a few others. And now that we captured kind of these challenge response handshakes, we needed some way to misuse them. The responses, they can't simply be passed in the same way that that original NTLM hash can. But they can be cracked if that original password wasn't well chosen. So to crack these responses, we added some new formats to John the Ripper to handle the network authentication captures, right? And John at that time supported your basic LM, NTLM hashes and had those formats. And we added ours, and we needed some way of differentiating ours from the existing ones. So we just prepended the names with net, and it became net NTLM, net NTLM v2. It's not an official term from Microsoft, but it kind of actually caught on. Hashcat a number of years later added their own algorithms to it, and they called it net. If you were to Google today on net NTLM, you're going to find all sorts of blog hits about it. But that just came out of us having to pick some letters to prepend the John format with. And we also added a rainbow table kind of update so that you could pre-compute hash tables using that fixed challenge of 1122, et cetera, that we'd put in that patch. Okay, so now let's jump ahead a bunch of years, right? And we're going to assume that every organization has solved the stupid password problem. Because a well-chosen password, again, is fairly hard to crack. But this is where authentication relaying starts to come into play. So the basic idea here is that you coerce some client into connecting to you, and you take that connection and you send it off to your actual target server. Server comes back to you with the challenge, you relay that to the client comes up with a response, you relay that to the server, you are now authenticated to the server, and you can tell the client to F off, right? And you are connected and good to go. So in a lot of these kind of relay scenarios, the attackers are doing this all over SMB, right? But they don't have to, right? Any network protocol that uses NTLM is potentially vulnerable to this sort of relay. For example, you can have responder kind of coerce that SMB connection, and I can then bounce it to HTTP, to a web service. And it was at DEF CON 20, so 2012, that this other team released this thing called ZAC attack, and it was really cool. At the time, it did NTLM v2 relaying and cross-protocol stuff. The tool is flawed, but it set the level kind of to move on and to do this thing. And then it was about 5 years later that NTLM Relay X was released. I assume some folks here have used it, right? It's the go-to tool these days for doing this sort of relay attack. Now, the key mechanism to defend against relay attacks is to enforce some sort of session signing. And by default, most protocols have this disabled, right? But it's relatively easy to turn it on for different things. So in the case of SMB, you can set these group policies and you enforce signing. You can't relay it. And when organizations started doing that, then pen testers moved on to other protocols, and they would relay to LDAP was, I think, generally the next one. Relay to a domain controller and do things, right? Here again, relatively easy to fix through group policy. So when that started happening, well, we moved on to ADCS, Active Directory Certificate Services, right? And that is the thing people are relaying to today, right? You coerce some connection, I relay it to ADCS, I can then enroll and get a certificate in the context of that original person connecting to me, or maybe I can add stuff to the subject alternative name of that certificate, some other identity. And if that thing gets signed, I can now be that identity, domain admin, whatever, right? Here again, though, there are controls. You can easily kind of prevent the relaying. So I was kind of looking around in the last year at what other things are potentially available that we can relay to. And I was playing with NTLM-X and thinking through this problem. And I ultimately landed on WinRM. So this is the service, right, that we use to do remote PowerShell commands on a host. In it, so there's two kind of flavors of WinRM. There's WinRM, it's typically delivered over unencrypted HTTP, so 5985 TCP, right? And there's also the version where it's over HTTPS, 5986. The HTTP version, it surprisingly encrypts the whole message body with the NTLM hash of the client, and because of that, it blocks us from successfully being able to relay it. It's kind of sad. The HTTPS version, though, does not encrypt the message body. They figure it's over TLS, right? It's already encrypted, why bother, right? But it does support these things called channel binding tokens, where enforced a CBT is going to break our ability to relay the request. Fortunately for us as the pen tester, WinRM has this default CBT policy of relaxed, which means if the client doesn't include a CBT, server's not going to try and enforce one. I should also note, though, that you can't actually, as a man in the middle, strip out the CBT because it's going to break other integrity checks. So you need the original client to come through without it. The SMB connections I was playing with initially, well, they had a CBT of all zeros, 16 nulls. So I'm like, okay, this is a win. The server is going to treat that as nothing and we'll be good to go. Sadly, that wasn't actually the case, and it broke the connection. This whole kind of process, it turned out to be a bit of an emotional roller coaster for me as I was testing different things. Some I thought were going to work, some ultimately didn't. And I started thinking like, okay, what else could I use to connect in? And it turns out that the WinRM client itself doesn't include this CBT value, right? So if I can coerce somebody to do a remote PowerShell to me, I can relay that to a WinRM over HTTPS server. And at that point then, it's like, okay, this is a win, but coercing that connection is hard. Like, yeah, how do I do that? It turns out you don't have to if you're in a big corporate network. Your friendly neighborhood corporate vulnerability scanner is usually going to come to the rescue, right? Because many organizations at the direction of the vendor will be doing authenticated vulnerability scans where they will plug in, again, at the direction of the vendor, administrative accounts, right? And it will do discovery. It'll just spray this across your environment. My experience is with Rapid7 Nexpos, so that thing generally does its authenticated scanning over WinRM. So if you're listing for it at the time of a scan, which is usually happening weekly, monthly, or whatever, daily, right, you can capture that, and you have the potential then to relay it. So I started playing with all of this, and let's see. I've posted my initial work to GitHub, because Nick, when I talked about it last time, was yelling at me for not. It's here, it's in a very crappy form. The POC there works for kind of the one-off connection. I can relay it. There's still some threading issues, I think, in NTLMX for the Nexpo scans, because it sends a bunch of them at you, and matching up the challenge with the right response isn't fully there. It'll get there, or maybe someone out here wants to take a stab at it. But it certainly looks like this is going to work. And again, just got to wait for the connection to come in, and you're good to go. So that brings us to the end of kind of my Windows password journey. I want to thank you all for hanging out late.
Thank you.
So. We have a few minutes to chat.
Yeah, I got a question.
Okay.
Okay. So, I've had a few of these 9.1% thingy beers.
Okay, drunk lady in the front has a question.
Yes, drunk lady in the front, anonymous. Okay, so instead of certified bind for something like WinRM, is there a GitHub page that you can, I guess, refer us to, or something for WinRM?
So is there a GitHub page for relaying to WinRM?
Because I'm not familiar with that. Like, I know, like, certified bind and, like, that kind of shit. Like, sorry,
Yeah.
excuse my language.
So
Children.
if you go to my GitHub page, right, and you go to, I've forked the Impact at NTLM project there. And I have my very rough code into my fork of it. I also have issues attached to that fork that document kind of the steps to reproduce this.
Wait, WinRM's not in packet, is it?
So WinRM itself is a protocol.
It's not in packet.
So NTLMX is part of InPacket. And this adds WinRM support to it.
Oh, okay, okay.
And then WinRM is the Windows protocol, right, for doing remote management.
Yeah.
WSMan, it's also called. It has many names. Okay. Any other questions? Yes.
Just kind of curious, like what your mindset was when developing these tools, and what the general process of where you learned to develop these tools were. As somebody who's kind of interested in developing their own tools, would be in like languages such as C, Rust, C++.
Yeah, so I had no experience when I joined the team developing that stuff. I was an intern on the team with them, eventually going full-time. And the tools got developed based on needs we identified doing assessments. So a lot of that code, Medusa, FgDump, was written on site at a client as we're testing things and finding vulnerabilities and coming up with ideas and bouncing stuff off each other. So it was just as needs arise, we answered them and looked for creative solutions. Again, this was 20-some years ago, so it was a different landscape, I guess, than today, right? People who were primarily sysadmins were getting into security, where today it's people are security pen testers first, with maybe a little bit of sysadmin background. And we in that era didn't have other tools to work off of. The folks today are much smarter. They have fancy frameworks and all of this stuff. We're just hacking things together back then. So it was different. I don't know. Yeah.
Did you find any ways to make the WinRM HTTPS less of an emotional roller coaster? Any hardening tips for that?
Oh, to fix it so you can't abuse it? Yeah, you can enforce CBT on it. So the default policy is relaxed. You can set through group policy that it be strict, and then it's always required that there be a CBT. But by default, again, it's relaxed, and I haven't seen others talking about this a whole lot, so I don't know how many organizations have flipped that value. Where I work, we have, because I made sure that was done, but before talking about this, but yeah. The bigger challenge, though, is probably your vulnerability scanners, right? And that this is how they work. Similarly with network discovery tools and all of that class, they're trying to find things that they did not previously know about, and then they spray credentials at it to learn about them. And you can abuse that. Anyone else?
I have one more.
Uh-oh.
This is gentle. How do you see the work that you did, you're like, hey, this is all new stuff, versus everything else that's new today? How do you perceive your development path in researching and exploiting vulnerabilities versus where we're at today, where we've got new technologies and new developing techniques of exploiting things? Do you think that there's a shortening of that divide between understanding how things communicate and exploiting them versus we're developing new technologies and shortening that gap in how to exploit them? I mean, how did your development process go with things in the past versus how you see things in the future? Are we taking the same steps that you did then, today, only because they're new technologies? Or, I don't know, what are your
There's many pieces to that, right? So how is development of exploitation methodology different today versus when we were doing it 15, 20 years ago, right? I mean, there's so many more people doing it today, right? And they're dedicated to it and they're trained in it, right? So I would think it's a lot quicker, and they also have solid frameworks to build upon. But also then the technology is probably more complicated today to find these flaws, and people releasing the technology in theory are doing their own testing, so it's maybe harder, and there's less of these stupid like old directory traversal bugs from yesteryear. I don't know.
Yeah, it's kind of, it's curious to see like the genesis of owner versus where something very refined and beautiful as Bloodhound. I mean, it's still applicable, but the development path was largely the same.
Yeah, so owner was one person, Foofus, writing this thing, right, and then talking about it and publishing it. Sharphound, they have a professional like development team working on that. They have GitHub pipelines and stuff. It's a very polished release process. It's real software. It's ultimately doing essentially the same thing, but in a scalable, cleaner fashion. All right. Well, if anyone has questions, feel free to come up and directly ask me. But thank you all.
Thank you so much.